Hello guys, welcome back to the channel. Today we are going to solve this Leetcode question, which is find bottom left tree value. So it's a medium question, and in this question we are given the root of a binary tree and we need to return the leftmost value in the last row of the tree. The question is very easy to understand. We're basically given the root of a binary tree. Basically we are given a binary tree and we just need to return the leftmost value in the last row. We just need to go to the last row, and in the last row we need to return the leftmost value. That's it. If you look at this example, in this tree the last row is this row and the leftmost value is 1, right? So the answer is 1. And if you look at this tree, the last row is this thing, and in this row the leftmost value is 7, and there is only one and only value, and that is 7, right? So it is the leftmost value. So we need to solve this question, and we're going to solve this question using two approaches. So let's directly jump into the approach one. So let's say we don't need to take care of we don't need to worry about constraints, because you know we're not going to add, or we're not going to do any sort of extra loops sort of things. So we don't need to worry about constraints for now, at least for tree values. I'm sorry, like not for all the tree values, for this problem especially. So let's directly jump into the approach one. Okay, let's look at this approach. In this approach, what I'm going to do is, let's say the value of this is 1, 2, 3, 4, 5, 6, 7, right? So what I'll do is, initially I'll take a queue. Initially my queue will have only my root, which is 1. So what I'll do is, for every for every iteration, I'll take the first value in the queue. I'll take the first value, you might say, and I'll say this is my leftmost value. Currently my leftmost value is 1, right? So now what I'll do is, I'll remove 1 from the queue. I'll remove 1 from to the outside, and I will add the both children of 1. The children of 1 are 2 and 3, right? First I will add the leftmost one, which is 2. Then I'll add the rightmost one, which is 3. And do we have any other nodes in the queue? We don't have, right? So this is the this is the queue in the second iteration. So in this iteration, if you look, 2 is the leftmost one. So my left will become 2, right? Now again, I will remove these two values from the queue, and I will add their children, right? Now what I'll do is, initially I'll remove 2, so there will be 3, right? But I will add both the children of 2, which is 4 and 5. Now again, I need to remove 3 as well, because 3 belongs to this level, right? So I'll remove 3 as well, and I will add both the children of 3, which is 6 and 7. Now if you look at this iteration, the leftmost value is 4, which is the leftmost value. So the left is 4. Now at the next iteration, I need to remove all these nodes. Currently, my queue contains these 4 nodes, right? I will remove these and I will add all the children. But if you look, these 4 nodes do not have any children, right? So my queue will become empty, right? I will not add null values. I will only add if there is any node as the children. So in the next iteration, my queue will become empty and I will stop. And at the end, if you look, my leftmost value will contain the value 4, which is the answer for this question. Now let's look at this example in order to get a better idea about this approach. So initially my queue will contain, Suppose this is value 1, 2, 3, 4, and 5. Initially my queue will contain 1 and my left will be 1, right? Then I will remove 1 and I will add 2 and 3 to my queue. So at this iteration, I need to make sure that I'm initializing the value with the leftmost value. Now the left will become 2, right? Then I need to remove these two nodes and I need to add these two nodes. How am I going to do that? So what I'm going to do is I will find the length of the queue. The length of the queue is 2, right? So I'll start a loop from 0 to 2, means it goes from 0 comma 1 and it stops for 2, right? So in this loop I'll remove these two items and I will add the children of both these nodes. Initially I'll remove 2. When I remove 2, I see no children, so I will not add any children. So the 3 will remain as it is and I will not add any extra children, right? So I also need to remove 3 as well. So when I remove 3, I can add 4 and 5. So at this iteration, when I removed all the nodes from the previous level, this is the nodes I have in my queue. So right now I need to update my left with 4, right? This is the leftmost value. So again, I will remove these two nodes and I'll try to add the next children of these two nodes, but I see there are no children, right? So the queue will become empty. When the queue becomes empty, I will stop. And at the end, the leftmost value is my answer. So let's try to code this up. So initially I'll take a queue. This queue will have my tree node. This is how we will create a queue in Java. And initially I'll add my root, right, to my queue. And initially my leftmost value will be root value itself, right? Now I'll go till my queue dot size is greater than 0. When my queue size becomes 0, I'll come out of the loop. So right now my left will be queue dot peak dot value. What I'm doing is I'm taking queue dot peak, means it gives the first value, and since we are having a reference, we need to call dot val. Since we are having the root reference, basically when we call q dot peak, we'll get the object of the tree node. So we need to call dot val on that in order to get the value. So after that, what we need to do is I need to loop till the size of the queue, right? So for I equals to 0, I less than q dot size I plus plus. Now what I'll do is I'll take the node tree node equals to tree node current equals to q dot poll. This removes the first value from the queue. Suppose if you want to remove 2 from here, this particular line does that. So if my current dot left is not equals to null, then I'm going to add the current dot left, right? And again I'll check for the current dot right. Not equals to null. I will add q dot add current dot right. Now after this, after I went through everything, that's it, right? After I come back out of the loop, I'll just return the value of left. That's it. Let's see if this works. Oh no, this is not working. So what's the problem here is Oh, uh, I got what's the problem here, we're always using the q dot size, right? When we are adding more and more values, it keeps on going and going. So what we need to do is we need to take the size q dot size, and I should be less than size. Now when we run this, it should run fine, I hope. Yeah, let's try to submit it. Yeah, it's working, and let's look at the time and space complexity of this. The time complexity is we're visiting each and every node only once, right? At any point of time, there is only one node in the queue, right? So we're not revisiting any nodes again and again. So the time complexity is order of n, and space complexity is, at most at any point of time, we're going to have either this level or this level or this level or this level or this level. Also depends on the maximum number of nodes present in a level, right? So it is a space complexity. So we can also solve this using another approach without using any extra space. So let's see how are we going to do that. Let me take some examples in order to explain. So let's look at this example. In this example, you look the if you look according to the question, the answer is the last to the leftmost element, right? Which is the answer is 6, right? So how are we going to do that without using any extra space? So what I'm going to do is initially I'll start from here, and what I'll do is at this level initially I'll take a variable called level. At this level the leftmost value is 1, right? So then I'll go to the right. Then I'll go to the right and sorry, let's suppose the level is 0, or we can also take it from 1 as well. Let's say we took it from 0. At level 0 the leftmost value is 1, right? Then I'll go to the right, then my level becomes 1. At level 1 the leftmost value till now is 3. The leftmost value till now is 3. So and again I'll go to the right. Again go to the right and the level is 2, right? So the leftmost value till now is 4. Then I'll again go to the right and I see there is null. So I'll just come back. From here I'll go to the left and I'll just come back. So since this node is completed, I'll go here, and from here I'll go here. And what's the level right now? The level is again 2, right? So from here the level is 1. We're adding 1 and we're passing it to the next level, right? So this is level 2, right? So this is level 1. So I'm adding 1 and sending it to this. So this is level 2, right? So when I encounter level 2 again, I'll just update my left. Now my left will become 5, right? Then this will call this thing, this will become null, this will become null, and this won't update anything. So, and again I'll come here and I'll go here. So here the level is 0. When I come here, the level becomes 1, right? So the level is 1. And my left value is for level 1, initially the left value is 3, right? But I found another left value, which is 2. So my left becomes 2. Then I'll come here I'm sorry, yeah, I'll come here and I see my level becomes 2, right? So for level 2, already the left value is 5, but I found a new one. So my left becomes 6, right? Then this will call the children, but I will not find any extra values. So I'll just go back. This will call its left and I cannot find it. So at the end, we will have the answer. But if you look, we're only updating the value when we found a new level, right? A higher level. So uh, let me explain you with another example so that you'll get a clear idea. Now let's look at the example. With this example, I hope you'll get a clear idea. So uh, initially my level is 1 and left value, my left value is also 1, right? Oh, I'm sorry. Initially my level is 0. This is the level 0. So what I'll do is when I'm calling to the right, I'll increase my level by 1. So when I encounter a new level which is greater than my existing level, I'll update my level. So my level will become 1 and I will also update my uh, left value as well. My left will become 3. So from here I'll again call to the right and I'll add 1. Initially here the level is 1, right? 1 plus 1 is my will become 2. When I encounter a new level, a higher level than the existing level, then only I'll modify these two values. When my level becomes 2, my left value will become 4, right? Then I'll call to the right, I'll come back, I'll call to the left, and I'll come back. And from here, I'll come back. And again, you know, call to level 2, right? Level 2. Oh, previously I said when I encounter in higher level, but we're going to update the values when we are encountering the same level as well. Like I have my level as 2. So if I encounter any values above 2, when I encounter another levels which are of level 2 or higher, then I'm going to update the values. So initially my here the level is also 2, right? So I'm going to update my left as well. My left will become 5. Again I'll call to the right, then my level will become 3. So this level is greater than this level, right? So I'll update my value to 6. Then I'll call to the right first and I'll call to the left. I'll go back and I'll go back and I will go back and I'll again call to the left. So here my level is 1, right? So, but here my level is 3, right? So I'm not going to update because this level is less than my overall level, right? So at the end I'll have my left as 6. So let's try to code this up. If we don't need a queue, so what I'm going to do is I'll keep a static int level equals to 0 and static int left value equals to 0. Initially I'll initialize these values with 0 and left value with root dot value. Then I'll call a traverse function which traverses the entire binary tree, and at the end I'll just return left value. I'll also pass 0. 0 means the current value. I'm sorry, current level. So this will have a tree node of root and int current level, right? So what I'm going to do is if my root is null, I'll just return. So right now, what I'm going to do is if my current level is greater than or equals to my level, I'll do two things. Then my level becomes current level and my left value will become root dot value. And I'll call to the right with my current level plus one. I said we'll add one, right? I'll call to the left with my current level plus one. So that's it, guys. I hope this should work fine, but I'm not sure. Let's submit this. Yeah, it's working fine. So if you look, it beats 100% because we're not using any extra space. The time complexity here as well is order of n since we are only visiting each and every node only once, and the space complexity is order of one, right? This is excluding the recursive stack space. So if we also consider recursive stack space, it should be order of height of the tree, height of tree. So usually we don't consider this. So the space complexity is order of one. So that's it, guys, for this video. And if you find the video helpful, just like. That's it. Thank you.